Hello, sir. Let me introduce myself. My name is Harsh Vardhan Jain, and my qualification is Physics MSc from DAU, and I have total experience of 20 plus years in this field, and I have helped many students to fulfill their dreams to become an engineer or doctor by cracking NEET and JEE. Hello. Hello students, today's lecture is based on the motion of a rod on a rough horizontal surface. And here what is this? A rod is kept in a horizontal surface in vertical direction. And there is a sufficient friction between the rod and the surface so that when it is let it go, when it is given a small tap at the top, it will start falling downwards. So in this lecture, we will see the trajectory of the center of mass, then the tangential acceleration, normal acceleration, and the normal reaction on this rod, and the trajectory of the center of mass. So as it is here at the time t is equal to 0, the center of mass and the whole body was and whole rod is at rest. And here L is the length of the rod and M is the mass of the rod. When it is given a small jerk, then it start falling. So its a future position, and future is like this. It makes an angle theta with the vertical at time t is equal to 0. Suppose we have to calculate here when theta is equal to 60 degree, what would be the value of tangential acceleration, normal acceleration, and the normal to the surface. Okay, so it is pivoted. We can assume that it is pivoted at this point because there is a sufficient friction between the rod and the surface. So the center of mass follows this mass, means center of mass loses its some height. So before doing this, we have to calculate omega and alpha. Omega is the angular velocity, and alpha is angular acceleration. Angular velocity can be calculated by using work energy theorem, and angular acceleration can be calculated by torque equation. So as the center of mass loses its height, so there is a loss in potential energy, and this loss in potential energy will increase in the kinetic energy of rotation. So omega can be calculated by using the work energy theorem. So work energy theorem, omega can be calculated by work energy theorem. What is that? So by doing this thing, center of mass loses some energy, some height, and this lose in height means it lose some potential energy, and this potential energy results into the increase in rotational kinetic energy, and the rotational kinetic, so this will come out mg L by 2 1 minus cos theta, and the moment of inertia of rod about one of its end is equal to 1 by 3 m L square omega square. And theta here, theta is equal to theta is equal to 60 degree. It means then cos 60 degree is equal to half. So mg L by 2, 1 minus 1 by 2 is equal to 1 by 2 into 1 by 3 ml square. Half get cancelled. So omega square cancelled, 3g by 2l, or omega is equal to under the root 3g by 2l. This is the angular speed of the rod when it comes to this position. Again, what is that? When the rod is let it go, it will follow a path. Means the rod will lose some of its height, and this height means it lose some potential energy, and this potential energy, lose in potential energy means gain in kinetic energy, as we know that from the work energy theorem. So due to which it will gain an angular speed is equal to 3g by 2l. Now we have to calculate the angular acceleration. For angular acceleration, we are required the torque equation. Alpha can be calculated by using torque equation, and here torque is provided by the gravitational force or weight of the rod. As the rod is falling downwards, the torque will act in this direction, alpha and omega. So this is in clockwise direction. So torque is equal to force into perpendicular distance. So perpendicular distance is equal to L by 2 sine theta, and this torque is equal to I alpha. We can then say that the summation tau is equal to I alpha. So this implies that I alpha is equal to mg L by 2 sine 60 degree, and I moment of inertia about this point, about any edge or any end of the rod is equal to 1 by 3 m L square alpha is equal to mg L by 2, and sine 60 degree is equal to root 3 by 2. L m cancelled, or L also cancelled. So alpha is equal to g root 3 into 3 by 4. So we can write alpha is equal to 3 root 3 by 4 g. This is, so alpha is angular acceleration. Angular acceleration with which it is falling. Now we have to calculate the normal acceleration and tangential acceleration. Normal acceleration is also called the radial acceleration, AR or AN, and this is our tangential acceleration. AR is equal to AN, normal acceleration. This is our normal acceleration, and which is acting towards the center, and the tangential acceleration it is perpendicular to the rod, which is, or you can say that it is perpendicular to the normal reaction. So AT is equal to tangential acceleration is equal to R alpha. So here R is equal to L by 2 and alpha. And here L by 2 and alpha is equal to 3 root 3 by 4 into G. It must be here L. So this is your L here also. L get cancelled. So 80 is equal to 3 root 3 by 8 G. Here it is a tangential acceleration. And the normal acceleration A n is equal to R omega square. So A n is equal to L by 2, 3 by 2 G by L. L cancelled. So normal or radial acceleration is equal to A n is equal to 3 G by 4. Now we have to calculate the acceleration of center of mass. For the acceleration of center of mass, we have to draw one more diagram, as the normal reaction, this is our tangential acceleration and here it is our normal acceleration, and this is our y-axis and here we are x-axis. So this angle is theta, this is also theta. So what is that? And theta is equal to 60 degree. So we can write it is 60 degree and here it is our 30 degree. So acceleration along y-axis will be 80 cos 30 degree plus an cos 60 degree. So ay is equal to acceleration along y-axis. This is the total acceleration, we can say that on the center of mass. Ay is equal to 80 is equal to 3 root 3 by 8 G, and cos 60 degree is equal to root 3 by 2 plus an. An is equal to 3 by 4 G and cos 60 is half. So ay comes out 9 by 16G plus 3G by 8. So the total will be come out, this is 15 by 16G. This is the acceleration along y-axis. Now, as the normal reaction is acting upwards and mg is acting downwards. So according to Newton's second law, we have summation F is equal to ma, or summation Fy is equal to ma. So the net force as it is moving downwards, mg minus n is equal to may. So this is mg minus n is equal to m 15 by 16g. So n is equal to mg minus 15 by 16 mg. So the normal reaction will come out mg by 15. This is the normal reaction acting on the rod when it is falling. So what we have learned till first of all, in order to calculate the and we have various methods to calculate it. I tried it. This is the shortest method to calculate it. So in this chapter, they can ask you anything. They can ask you the AN, AT or normal reaction. And last thing is the trajectory of the path followed by the center of mass. So what would be the trajectory of the center of mass? So it is very easy to calculate the trajectory of the center of mass. Trajectory of center of mass. So what we do, we have to draw one more diagram for that purpose. It is very easy to calculate it, as this is your theta and suppose this is L. So we can resolve it L by 2 into two components. So its x component is equal to L by 2 sine theta and y component is L by 2 cos theta. So when you square and add them, x square plus y square, that it will come out L by 2 whole square sine square theta plus cos square theta. So x square plus y square is equal to L by 2 whole square. This is the standard equation of circle. So we know that the standard equation of circle is x square plus y square is equal to r square. So this is an equation of circle, center at the origin and the radius is r. Center at the origin and radius r. So in this lecture we have learned what is the behavior of a rod. So rod is falling on a frictional surface, and here one thing is very necessary, there is a sufficient friction. There must be a sufficient friction between the rod and the surface so that the rod doesn't slip on the surface. We can also calculate what should be the minimum value of mu so that the body doesn't slip. So for that condition we will discuss this next lecture, but here we assumed it there is a sufficient friction between the surface and the rod. So as the rod falls, it loses its potential energy. That potential energy converts into the rotational kinetic energy because it is rotating. There is no translatory motion takes place. So here, in order to calculate the AN and AT, we have to calculate the omega and angular acceleration. For angular acceleration, we have to follow the conservation of energy or work energy theorem. And second, in order to calculate the alpha, we have to use the torque equation. So I think you enjoyed this class and hopefully you understand this thing. Thank you.